E today. In this lesson, we will be beginning our work with the number E. Okay, so I guess it's not a letter E, it's a number. And that number, just like, when we're given pi, we know that that's 3.14 in mathematics. Now, E in mathematics stands for 2.71828183, and it continues on forever. It's one of these numbers, just like pi. It doesn't end, it just keeps going on forever. So usually if you use the letter or the number E, you want to take it out 3 decimal points. The number E is one of the famous numbers in mathematics. As your mathematical studies progress from Algebra 2 through calculus, you will discover that the role of E in mathematics is equal in importance to that of the number pi. Pi is the ratio between the circumference and diameter shared by all circles. E is the base rate of growth shared by all continually growing processes. So you're going to, if you're in science and stuff like that, you're going to see the letter E also, because when you start doing exponential decay and exponential growth, E is one of those numbers that you're going to be using. Now, when you graph something, like if you graph f of x equals e to the x, this is an exponential function, just like we've been talking about. So really, it would just be the graph of 2.71 to the x power. So we know that 2 is greater than 1, so we know it's going to be an exponential growth function. So if we graph it out, it would be this red one right here. So y is equal to the x would be the blue one, y is equal to 3x would be this other blue one, and the red one would be y is equal to e to the x. So it is an exponential growth function. And that's basically all you're going to have to know about it. There really isn't any questions on the assessment. Well, I shouldn't say that, because when we start doing continuous compounding interest, the letter E is in there. So just want to tell you what it is, so you know that it doesn't strike you funny that we get this. If you're going to graph e to the x, the same transformations hold true when we're doing exponential functions. For example, if I asked you to graph e to the x and then e to the x plus 2, well, we know adding a number to the backside of it is just going to raise the function up 2 places. Okay, so none of the things that we've learned about transformations are going to change. Now, if you put a number, if you have e to the x and then you do e to the x plus 2, guess what? That's the transformation where it shifts it left and right. So I'm adding 2, so it's going to shift it backwards 2 units. And you can see on this graph, the red one is shifted back 2 units. And if I did x minus 2, it just shifts 2 units to the right. So everything that we've dealt with graphing functions stays the same with e to the x. You just have to remember that e is 2.718. It's one of those numbers that when you have a function, e is a constant number. What is compound interest? Okay, so now this is the majority of this week's material, okay, compound interest. If you walk into a bank and open up a savings account, you will earn interest on the money you deposit in the bank. If the interest is calculated once a year, then the interest is called simple interest. If the interest is calculated more than once per year, then it is called compound interest. This is the formula, okay, for compound interest. The mathematical formula for calculating compound interest depends on several factors. These factors include the amount of money deposited, called the principal, the annual interest rate in decimal form, the number of times the money is being compounded per year, and the number of years the money is left in the bank. These factors lead to the formula f of v, the future value, okay, is equal to P, which is the principal or amount of money deposited. I always call this the original amount that you put in. Okay, I'm going to change this thickness of my pen here because it's a little bit too thick there. Okay, so that's the original. I always call this the original amount that you put in. And then 1 plus R, well, R stands for the interest rate in decimal form, over N, and it's the number of times you're compounding per year, to the nt power. And it's the number of times you're compounding per year T is the number of years that you're using. Now, if you did simple interest, then it's a much easier formula. It's just f of e is equal to p 1 plus r to the t power. Now, the only thing that changes in this formula when you're compounding per year is that the n. You see the n, the number of times you're compounding it, so that becomes your n value, and you divide this by n and you multiply by the n here. So that's the only difference. So if you knew the simple interest formula, then just tacking on that n when you're compounding is what you do. And n, you know, if they say you're compounding monthly, then n would equal 12 because there's 12 months in a year. If they say you're going to compound daily, so n would be 365 because there's 365 days in a year. So n is the number of times you're compounding. If they say you're going to compound quarterly, that means you're going to compound 4 times per year. So your n value would be 4. So n just stands for how many times you're going to compound that money every year. So in this problem, it says if you deposit $4,000 into an account paying 6% annual interest compounded quarterly, how much money will be in the account after 5 years? Okay, so the original amount, I take 4,000, okay, because that is my original amount. So this is going to be 4,000, and then 1 plus, well, 6% is not a decimal. I have to change 6% to a decimal. Well, I moved the decimal point over 2 places, so this is going to be 0.06 compounded quarterly. So that means 4 times a year. And then I'm going to raise it to the 4, so n times t. Well, t is 5, so 4 times 5 is 20. So all I have to do is plug this into my calculator, my trusty calculator, and I do have my calculator with me today because these would be really hard to do without a calculator. So I've got 4,000, and then 1 plus 0.06 divided by 4, and then I'm going to raise it to the 20th power. And I end up with $5,387.42. Okay, so I deposited $4,000 into the bank. After 5 years, at 6% interest compounded quarterly, I would have $5,387. So I really made $1,387.42 for just letting my money sit in the bank for 5 years. Okay, so that's called compounding interest. This is the interest that we've made off of the original $4,000 that I put into the bank. Okay. If you deposit $6,500 into an account paying 8% annual interest compounded monthly, how much money will you have in the account after 7 years? Okay, again, the original amount. Well, I'm going to put in $6,500. 1 plus the percentage. Well, 8% is really 0.08 over, I'm going to compound monthly, so this is going to be 12 here. And then raised to the nt power. Well, I usually just multiply that out. So that's 7 times 12. So that's 14. So that's 80. So it's going to be to the 84th power. And then now all I have to do is plug it into my calculator. So I've got 6,500 parentheses 1 plus 0.08 divided by 12 parentheses raised to the 84th power. Oops. Oh yeah, I get that right. So I'm going to end up with $11,358.24. So I've almost doubled the amount of money that I had just by putting it in a bank, letting it sit there. Okay. Now, I will tell you that rarely will you get 8% interest from a bank. Most of the times you'll get 2%, maybe 1 or 2%. 8% is pretty high. Now, if you put your money into like some CDs, things like that, you could probably get 8%. But leaving that kind of money sit for 7 years, it's a long time. You do get penalties if you draw it out early. Okay, if you do a CD. Okay, but this is called compounding interest. you make money for, you're basically letting the bank use your money to make other money. Like you put money into the bank gives it to other people for loans for houses and cars and stuff like that. So they're basically paying you to use your money. Now, obviously, they're making more back. So if they're giving you 1 or 2% interest, trust me, they're getting 3 or 4 or 5% interest off the money that they are lending out. Banks are always making money. Yeah. All right. So in this next problem, it says you deposit $300 into an account that pays 1.48% annual interest. What is the balance after 1 year if the interest is compounded daily? All right. Now, I always try to figure out what I think the answer is going to be. Now, 1.48% is pretty small interest. I don't think it's going to be a real lot of money, especially after just 1 year. If I had to guess, and I'm just guessing right here, I'm just going to say D, but that's just a guess. Okay, so now I'm going to work out the problem. So I've got 300, and then 1 plus 1.48, well, that's going to be 0.0148, isn't it? I'm just moved the decimal point 2 places over. Compounded daily, it's 365 times, and this is just 1 year, so I just go 365 up there. Okay, so I've got 300 times, and then 1 plus 0.0148 divided by 365, all raised to the 365th power. And I come up with, oh, I was right, $304.47. Boom, so I did guess it right. I learned a rule back when I was in school that if you have 7% interest for 7 years, you will double your money. It's called the 77 rule. So if you took $5,000 and it was a 7% interest, and I think this is continuous interest for 7 years, you'll end up with $10,000. So in my mind, that's what I always think about when I'm doing these types of problems. And it's like, okay, this is way less than 7% interest, and this is way less than 7 years. That's why I was thinking it wasn't going to be a whole lot of money that they were going to gain there. All right, let's talk about the PERT formula. If you are asked to compound something continuously, what number would you use? 1 million, 2 million, 3 million? So we could, let's just do an example. Let's say I had a problem and I said you're going to put $5,000 into the bank and you're going to compound it, let's say at 5%, and you're going to compound it 1,000 times. Okay, so if I did my work here, I'd go 5,000, and we're just going to do this for, let's say, 1 year. Let's go 5 years. Okay, so I've got 5,000, and then 1 plus 0.05 over 1,000, because that's my n value, and then that would be 5 to the 5,000th power, right? Because n times the number of years, number of times I'm compounding. So I've got 5,000, 1 plus 0.05 divided by 1,000 raised to the 5,000 power. Okay, and I end up with $6,420 and like 7 cents. Okay, now let's say I said I'm going to compound this 10,000 times. Okay, so I'll put 10,000 in there, and this would be here. So now I'm just going to go back. I'm going to redo that problem. I'm just going to insert another 0 here. So that's 10,000. I'm going to raise it to 50,000. Okay. So that gives me $6,420.12. Okay, so I get a little bit more, not much. So once you start compounding like 10,000, it's not going to change much. This is compounded continuously. This would be the best you could ever do. So you could put 1 million in there, and it'll probably come out to be almost identical. But this is the PERT formula. And there's the E that we learned. So P stands for the principal, R is the interest rate, T is the number of years, and E obviously is 2.71. So if I did this problem, same problem up here, I've got 5,000 E, and there is an E button on your calculators, and then R is, what is that, 0.05 times the number of years, and we said 5 years, right? Okay, so I'm hoping my answer is going to be very close to this, right? Because we compounded that 10,000 times, but the PERT one is continuously, so it probably is going to be a little bit more. It might be 13 cents or 14 cents, you know, but it's going to be a little bit more because it's continuously compounded. So I've got 5,000. Where's my E button? There it is. E raised to the 0.05 times 5. And I end up with 6,420 and 13 cents. So I came really close when I used 10,000 in there for the compounding. There has to be a limit, and this is the best you could ever get. Most banks do compound continuously nowadays. Back in the day, they did not, but nowadays most banks do, and you can ask your bank how many times they compound. But this is, I think this is one of the coolest formulas there are. It's called the PERT formula. So if I gave you a problem like this, I said, find the amount after 7 years if $100 is invested at an interest rate of 13% per year compounded continuously. Okay, so I'm going to use the PERT formula. Compounded continuous, think PERT. So I start with $100, E, and then raise to the, what is it, 0.13 times, what was that, 7 years? So that's it. That's my whole formula there. Okay, so 100. Now, if I had to think about this problem, I'm going to think my answer is going to be a little bit more than 200, right? Because, you know, if my rule of 77 works, and I don't know if it does or not because I've never really sat down and thought about it, but I've got 7 years, $100, 13%. 13% is more than 7%. So I would think that my answer is going to be more than $200. Just spitballing it there. So I've got 100. Let's see, where's my E button? Here it is. E raised to the 0.13 times 7. And I end up with $248.43. Boom. I love this stuff. I think you guys are going to enjoy this week. It's not a real difficult one, but you do have to know the formulas there. All right. Hope to see you guys on Monday to go through all the practice problems. Have a great week. Bye.